Hello everybody, this video is going to be about general overview of Mento v3, the new version of our protocol, and this aims to give you a general overview of what we are doing with this new version. Mento v3 is an evolution of Mento protocol, transitioning from a reserve-backed stablecoin issuance and swap protocol to a CDP-backed foreign exchange protocol. V3 enables fixed-price stablecoin swaps through a market maker contract, which we call FPMM, liquidity management through rebalancing strategies, and user-driven issuance through CDP. CDPs are basically uses like this mechanism uses liquidity v2 fork, and we can evaluate the whole system in two parts. The first part being the liquidity v2 fork, which we use for issuance and redemption of stable tokens, and the second part being our core contracts, which are mainly FPMM and liquidity strategies. So in this first part, I will go through the changes that we introduced to liquidity v2. I'm not going to go into the details of liquidity v2, but I will more talk about the changes that we did. If you need more information about them, you can go to their GitHub page and check their documentation. So we slightly changed liquidity v2 to fit our own needs. I think I can start with system params contract. So this contract doesn't exist on liquidity v2. This is where we keep all the configuration variables of the liquidity v2. In their case, I think they keep it under the constant contract, and I think they also have some configuration in the address registry contract. But in our case, we moved them all in this new contract called system params. Everything here is immutable, and what we wanted to achieve with this is we wanted to make this values upgradable, but without actually having storage reads for each configuration read. So if you want to update any variables here, we need to basically update this contract, and each read call to this contract will be basically not reading from the storage. Instead, everything is immutable, so they're going to be baked into the bytecode of the contract. So we wanted to reduce some storage reads here. The next change that we did is this new contract called batch manager operations. It's not like we don't have any logic change here. Basically, it's still like it's borrower operations contract, but after our changes, this contract was over the contract size limit. So this is why we split them into two contracts, one being batch manager operations, the other one being borrower operations. But logic-wise, it should be basically the same with how liquidity v2 works. The next thing I want to talk about is liquidity-based init contract. This is basically a liquidity-based contract, but we made it initializable because we also have upgradable contracts in our system. So our stability pool contract is upgradable, and since it is upgradable, we needed to have an upgradable version of the liquidity-based contract. This is why we created this new contract, but this one also should be the same logic-wise with the original liquidity-based contract. The next thing, and I guess the more important changes happened here in the stability pool contract. And when you go here, there is a function here called swap collateral for stable. We introduced this function for the basically in our system we need access to liquidity for our rebalances. So liquidity strategies, when they need to rebalance a pool, they need to have access to some liquidity. And in this case, we use the stable token liquidity inside the stability pool as a source for liquidity for those rebalances. How it works is very similar to liquidations. So when there is a need for liquidity to execute a liquidation, So liquidity v2 uses the liquidity, the funds inside this pool, and instead move the collateral in, like it uses the stable tokens here to pay the debt, and takes the collateral from the liquidated position and puts it inside this pool. We do a very similar thing with rebalances. When we need access to stable tokens, liquid strategy is going to move some stable tokens out from this pool, and instead we'll move some collateral in, which is going to be separated or distributed to the LPs of the stability pool. We use the same accounting mechanism that liquidation uses, and other than that, maybe one other thing that we need to mention here is we introduced this new variable mean bold after rebalance, which ensures that rebalancers or liquid strategies don't drain this pool basically. So there has to be they have to leave some tokens in. The next thing that I want to talk about is this other contract called FX price feed. So we basically changed or updated how we interface with the price feeds, and we basically have an Oracle adapter contract, which we're gonna talk about later in the Mento core components. But basically, we use this FX price feeds contract to interface with Oracle adapter to get price information. Maybe one other thing to mention is, as you can see, we don't have the bolt token contract because we removed it. Instead, we use our own stable token v3 implementation, which we're gonna talk about later in Mento core components. But in theory, that should be also compatible with Liquidity v2 because it's also gonna be used by Liquidity v2. Yep.
All right. Now let's take a look at the changes we made to the Mento core repo. This repo contains the smart contracts around exchanging Mento assets for one each other. The main contract used for this is the FPMM, which is a 2-asset pool and is based on Uniswap v2, with the main difference being that instead of using reserve size pricing, we use Oracle-based pricing. So we use a concrete rate, and this is used to price and swap no matter the swap size. The most important functions in the FPMM are the swap function and the rebalance function. In general, the swap should always increase the total value of the pool by the swap fee, while the rebalance is allowed to decrease the total value of the reserves by a rebalance incentive. The swap also supports flash loans together with a hook function that is called on the caller. The rebalance works similar in that sense, but the rebalance is a whitelisted functionality. All right, the next contract is the one-to-one FPMM, which is based on the general FPMM contract, but instead of using an Oracle rate, it exchanges assets at a fixed one-to-one rate. This is used, for example, for token pairs like USDC against a second USD-based stablecoin. We also have an FPMM factory, which is used to deploy the same pools for the same two assets to the same address across different chains. Therefore, we use create3. It also keeps track of deployed pools and registers implementations. We also have a factory registry. This contract manages approved pool factories and is forked and modified by Aerodrome. It is also used in the router to determine which pools are supported in swaps. Then we have liquidity strategies, which are used to rebalance FPMMs if the reserve prices, so the difference between the size of the two reserves, differs too much from the oracle price. We have an abstract base class, which is the liquidity strategy, and then we have concrete implementations for different setups. Currently, we have the reserve liquidity strategy, which handles FPMMs that where one of the tokens can come from a reserve contract, so it taps into the liquidity in the reserve contract in order to rebalance the pool. And then we have the CDP liquidity strategy, which does the same thing, but instead of having a reserve, it uses a liquidity v2 CDP deployment to both expand on the debt token side of the FPMM as well as contract and get additional collateral into that FPMM. The next contract is the virtual pool contract, which allows us to integrate both Mento v2 pairs and Mento v3 pairs into the router contract, and also enables us to route through both versions of the protocol. This contract will be used until we deprecate Mento v2. The virtual pools also have a factory, which allows us to deploying virtual pools as well as keeping track of existing deployments. The router contract is the main entry point for users to the protocol. It allows people to perform swaps and route them through both Mento v3 and Mento v2, as well as wraps around liquidity provision. We also have an Oracle adapter contract, which exposes all Oracle-related information to the Mento v3 protocol. This means it exposes the rate, but also information around market conditions, as well as circuit breakers. All right, the next contract we're going to take a look at is the Oracle adapter. This is the central place for Oracle-related information in Mento v3. It aggregates both price data from sorted oracles, which is a v2 contract, as well as circuit breaker data and market condition data from the breaker box, which is also from Mento v2. And one special breaker that is new with Mento v3 is the market hours breaker. This contract stops trading outside of market hours. These market hours are defined by the chain link price feeds that we use. So, for example, on weekends and holidays, we don't want to use their rates, even if they push some, and therefore we implemented this breaker to prevent trading during these times. We also created a new version of the stable token contract. This contract combines both requirements from liquidity v2, so in order to be used instead of the BOL token, as well as compatibilities with Mento v2 and also our cross-chain partner Wormhole. For this reason, we also have a stable token spoke contract, which will be the spoke contract for a cross-chain Wormhole deployment. So this contract must be compatible with the Wormhole cross-chain standard. We also created a new version of the trading limits. Mainly we just updated some small things around like configuration, but this contract specifies an amount of net flow that can go through Ampere in a certain period of time. We also created a new version of our reserve contract. So previously we were just using the reserve.sol contract, which was very old and had a lot of unused functionality, which we got rid of and also upgraded it to a newer Solidity version and used some newer libraries. All right, thank you for listening to this and good luck with the audit.